So we're gonna focus on the topic here is simplify simplify radicals. Okay, so in order to do that, this warm up is important. You have to know your perfect squares, your perfect cubes, your perfect fours. Okay. Um, perfect squares are basically your 1, then 4, then 9. Basically, the numbers whose their factors are itself. Like 1 times 1 gives you 1, 2 times 2 gives you 4, 3 times 3 gives you 9. So you should at least get to the first 15. So after 9 would be what? Because I did, yeah, 16. Yeah, 25, 36, 49, 64, 81, 100, 121. Oops, I didn't write that right. 121, 144, 169, and so on. It keeps going. For cubes, perfect cubes, these are numbers that you're raising to a power of 3. So 1 is a perfect cube because 1 times 1 times 1, 1 3 times is 1. To get the next perfect cube, you take the next number. Let me get my calculator, which is not opening for some reason. It would be 8. In order to get that number, you would have to say 2 to the third power, and then 3 to the third power. So it'd go 8, 27, I think 64. So 8, 27, 64. 5 to the third power is 125. 6, that one I forgot. I think it's 2 something. Nope. 216. Then 343. 512. 729, and so on. So you take the number and you raise it to the power of 3. So perfect fours are taking the number and raise it to a power of 4. So again, we're going to start off with 1, then 2 to the 4th power is 16, 3 to the 4th power is 81, 4 to the 4th, 256, 625. I think that's right. Yep, okay. Then 6 to the 4th power, 1296. 2401, 4096, and so on. The pattern goes on. So these are the numbers. These numbers, whether I have a square or cubed or fourth, these are the numbers I'm trying to use to factor when I simplify. Your parts, we've already kind of talked about this. The number outside of here, this box is pointing to this end. That is your index. Okay, that tells me if you have a square, a cube, or a 4th power, or something greater than 4. This is pointing to the actual radical sign. And underneath the radical is called the radicand. The A here is the radicand. So it tells us right here, if there's no index, it is assumed that it's a 2. So if you don't see a number, you assume it's a 2. All right, so these give all possible roots to the radicals below. All these are perfect squares or cubes or roots. So square root of 16, that would be plus or minus 4. Square root of 121, that's the plus or minus 11. So if you're not sure, you could put it in the calculator, hit the blue second button, then the x squared button, and then type in the radicand, the number underneath, and we get our answer. Okay, so our first set here are going to come out nice and sweet. So this one is plus or minus 17. This actually comes out to be plus or minus 2/5. Now, cube root, that's when we have to hit the math button and pick the one with the index of 3, which is 4, and then put your radicand. So if it's odd, then we just have a positive answer. Or basically the answer is the same sign as the radicand. So this was 8 is positive, so this is 2. The 343, the cube root of 343 is 7. That's a 7, sorry. But now since there's a negative here, this would be negative 5. So when it's odd, you keep the sign. You don't have plus or minus. So this would be a negative 1/3. And then if it's even, then we have a plus or minus. So this is plus or minus 1. I think this is 7. So do the 4th root, hit the math button, pick number 5, put the index as 4, and then the radicand for 1. Yep, 7. All right, so this is plus or minus 7, and this is plus or minus 3/2. Oh, sorry, the plus or minus 7 goes here. I put it in the wrong spot. This is plus or minus 8. That's plus or minus 8. So the rules here, if it's even and the radicand, that's your number underneath is positive, then the root is real. Okay, it exists. And you would have 2 roots, one that's plus, one that's minus. If it's odd, the index is odd, the radicand is positive, again, you have a real answer, and it's just 1 root that is positive. If it's odd and negative, still you have a real root, 1 root, and it would be negative. But if it's even and negative, then it's not real. It's what we call imaginary. Sorry, I misspelled that. But you're still going to have 2 imaginary roots, 1 plus or minus. Okay. So they're just telling you here for this, for simplifying, if you see a radical sign and it has more than 1 root, the radical sign indicates the principal root, which is the positive root. So now we're going to get to simplifying, because in this section on the front to the back, they're not perfect squares anymore. This is why I think you just simplify. So in order to simplify, you want to pick the largest perfect square or cube, dang it, sorry, as a factor. So the big way I know if it's not a perfect square, put the actual radical in the calculator first and see if it comes out to be a whole number. Okay, so if this right here, we have root 17. When I do square root of 117, 117, it's a decimal answer, which means it's not a perfect square. Okay, so if I get decimal answers, that tells me I have to factor. I got to find a number, basically. I have to pick a number from up here. These are perfect squares. That would go into 117. So you got to divide. I tend to go to something that's the closest, like 100. It's a little too big, so I want to kind of check one of these to see if it goes in 117. So, or you can start from the beginning. 1 goes in everything. So 117 is odd, so I'm not really going to pick a 4. So then I can check this next one. Does, basically on the calculator, can I divide 117 by 9? That's what I'm checking. Yes, because it goes into evenly, and I want to use 9 because 9's the perfect square. And whenever we have a radical symbol, we're trying to pick perfect squares. So the way this gets broken down is I tend to write my factors that I'm picking underneath the radical. I know 9 times 13 gives me 117. Excuse me? Then what I tend to do is, so I know which one is the perfect square, I square that number. This tells me that this number is going to be gone, and it's going to come out as the square root. When I take the square root of 9, it's 3. And the one that's not a perfect square stays underneath the radical. So the 3's outside, then the radical symbol, and 13's inside the radical. And this is the simplified answer. So what we're doing here is we're trying, 320 is not a perfect square. But what perfect square goes into 320? So look at the top here. Find a number in this first list that would go into 320. I gotta pick from the top one. You need to pick from this list. 64? Okay, all right. So 320 divided by 64 gives me 64 and 5. So those are the two factors we're using. So when I write this, notice that this 4 is already on the outside here. So it stays on the outside. So the 4 stays there. Underneath the radical are the factors, 64 times 5, like that. The 64 was the perfect square. So I'm putting a square around that to let me know that that number is gone. When you take the square root of 64, it becomes an 8. So that 8 comes outside with that 4. Whatever is outside the radical is multiplied together. 5 is not the perfect square, so it stays underneath the radical. So now all I'm doing is saying 8 times 4, which is 32, root, then 5. This is the final answer. And then the way you can check if you did it simplified all the way correctly, if I put 4 root 320, I get this decimal, 71.55417. If I put 32 root 5, I get the same decimal. So you should get the same approximate answer. Does that make sense how to check? All right, so now this has an index of 3. So you need to be picking from the cube numbers. Starting at 1, then 3, 27, 64. Okay, so which one of these numbers goes into 48? Well, which one? Yeah, 8. 8 goes into 48. 8 times what? So this is written Your 2 stays outside the radical. Underneath the radical, you're going to have, 8 times 6. 8's the cube root. So the 8's gone and comes out as a 2. So you have 2 times 2 left with that cube root, of 6. So the final answer really is just 4, because you do 2 times 2 give you 4, cube root of 6. So another way people do it sometimes is they do a factor tree, a prime factorization. So I want a perfect cube that goes into 108. That's saying 27 times 4. So you're going to take the cube root of that 27. We already have a 3 on front, and then you're going to take the cube root of that 4. Well, the cube root of 27 is 3. So you're saying 3 times 3, which is 9, leaving you with the cube root of 4. If it's not a perfect square, or a perfect cube, that number should stay underneath the radical. Yes, Jose? Mm-hmm. Okay, so on the practice here, we're not going to keep simplifying, but now we're going to add exponents. So if you flip it over to the back, I'm going to focus on the adds with you, and then you're going to do the evens. So we have another one. We have a cube root of, there's the 3, the index of negative 250. So because it's negative, our final answer is going to be negative. If I want a cube that goes into 250, that would be 125 times 2. 125, this is the cube root. That's gone. And when I take the cube root of that number, it becomes 5. So this would be a negative 5 cube root. That's a 3 right there, of 2. That's my final answer. It's negative because we had a negative underneath. Now in 6 here, we already have the 6 outside the cube root. I'm going to take out the negative 1 because 1 is a perfect cube. So if I do a negative 1 times 2, that gives me a negative 2. And this negative 1 is the cube root. So when it comes out, it's just a negative 1. So on the outside is the negative 1 times the 6. Left inside is the 2. So the final answer is negative 6, the cube root of 2. So for a quartic root, or root of 4, 81 can go into 162. Oh, that's supposed to be 4, sorry. 81 times 2 gives me 162. And 81 is the perfect cube root, quartic root, excuse me. So when it comes out, it is 3. So what we have is 3 times that other 3 we had with the quartic root of 2. So the final answer here is 9, the 4th root of 2. So for 2,592, I'm just gotta go back to the front page real quick. I'm trying to pick for one of these numbers right here to go into that. It would be this 1296. If I double that, that's 259.2. So I'm picking that number as a perfect of fourth root. So the 5's outside. There's the 1296 times 2. This is what is the perfect root of 4, which is 6. That 6 gets multiplied to that 5, so the answer is 30, fourth root of 2. Now, for exponents, for radicals, or for when you're taking the roots of variables, for it to be, whenever you have exponents, it must be a multiple of 2. For cube roots, it must be a multiple of 3, and fourth root, it must be a multiple of 4. So we learned, or we did last week, it's just understanding, take that exponent and divide it by the root index. So this can be written as taking the square root of 32 times x to the 4th power divided by 2, and y to the 9th power divided by 2. (32) is not a perfect square, but I can break it up into a perfect square of 16 times 2. So 16 is the perfect square. The square root of 16 really is just 4. So the 4 comes out. Then when I look here, 2 can go into 4 2 times evenly. So this actually just becomes a 2. 2 can go into 9 actually 4 times with the remainder of 1. Right? So the 4 is outside the radical. The x squared is outside the radical. The y to the 4th power is outside the radical. Remaining inside is the 2 and the y that had a remainder of 1. So I just can keep it as just y. And this is the final answer. So I tend to factor just the numbers and then divide the exponents. Remainders stay in, whole numbers come out. All right, so now the index is 3, so I'm dividing everything by 3. The number I'm breaking down to the cube, perfect cube of 64. No, actually that's a perfect cube, I think. Yeah, it is. 216 is the perfect cube. This is perfect. This is 6. This comes out. We get 6. I'm dividing this by 3. That's just m. Divide that by 3, n squared. All right. All right, so on this one, 64 is not a perfect cube, but you can use, what is it? Is 64 a perfect cube? Oh yeah, it is. That's right there. I was thinking 4th root. All right, so 64 is a perfect cube, so that comes out. Then we have 10 divided by 3 and 21 divided by 3. The cube root of 64, when I bring it out, is a -6 because we had a negative sign there. This would be 3 can go into 10 3 times. This has a remainder of 1. 3 can go to 21 7 times. So the remainder stays in. So we have a remainder of, and that should be cube root, sorry, of x, 1x. Oh yeah, it is 4, not 6. Sorry. Negative 4. Alright, so on 15 you just have variables. Think of it as 4 divided by 4, power of 4 divided by 4. Oops, that's a v. And a power of 17 divided by 4. So 4 can go into 17 right here 4 times, which is 16, with the remainder of 1. So this would be v to the 4th power, and underneath the 4th root is 1v. So you have w v to the 4th root of v. So we're going to do the 4th root of 625, then c to the 23rd power divided by 4, and d to the 11th power divided by 4. This is a perfect, this is a perfect 4th root. That comes out to be 5. 4 can go into 23 5 times, which is c to the 20th power, with the remainder of 3. 4 can go into 11 2 times, so d to the 2nd power, also a remainder of 3. So underneath our 4th root would be c to the 3rd power, d to the 3rd power. Alright, so what I would like for you to do is try to do the evens and then put this in the tray when you're done. We'll go over it tomorrow.